So weathering is the breaking down of rock by rain, frost, wind, and other elements. No transport is involved, meaning no movement. Nothing is flying away, the wind's not taking anything, nothing's blowing out of place. Weathering can be physical, involving abrasion, or the wearing away of the surface, so like sandpaper basically, or changes in temperature, or something is heated up a lot or cooled really well. And that can cause expansion, and that is considered physical. It can be chemical, involving chemical reactions, or it can be organic, involving the action of living things. Which of the following example of physical weathering? So we go back up here, look at physical, which is involving abrasion or changes in temperature. So then you go down here and look, okay, so the cracking of granite from the expansion, okay, that's physical because it's expanding. Also, and it's from freezing water. So it cracks, physical, and it's from cold ice water. That's going to be your answer. Breakdown of calcite, that's going to be a chemical, just any kind of breakdowns like that. Transport of sand, like it said, it doesn't involve any transport. It says it directly right there. No transport. So that one's not going to be your answer. And then the breakdown of crumbling rocks in the soil by burrowing worms, that's going to be organic because it involves the action of living things. So your answer is A, because cracking granite from expanding cold water. When removed from the body, large organs live only a few hours or days under cold conditions. Therefore, organ transplants must be performed quickly. Many organs go to waste because the organ cannot be transported to an appropriate patient in the short time available. Unfortunately, it is not yet possible to freeze large organs to preserve them for a longer period, meaning they can cool them down, but they can't freeze it because that'll cause the cells to break down and ruin the organ. That's because they contain many types of different cells, all of which react differently to freezing. Some cells are even destroyed by ice crystals. So if you freeze an organ and just put it on ice, it can ruin that organ. So you can't use it, and then you're going to be at a loss. So which of the following studies, which of the following ideas, is most likely to yield information that might help solve the problem for freezing whole organs? How the time it takes to locate patients who need organs can be decreased. That doesn't really answer it because it has nothing to do with freezing the organs. That has with how do you get them there. So whether it's like an ambulance, whether it's a helicopter, and that's how you get the organs to the patient. Also, it's also like if there's a national database of donors, locating that patient quickly. So that's about the patients, not so much the organ. Time to transport, like I said, that's helicopter or ambulance. What's the best way? So we're not talking about the organs really. We're talking about how we get there. How special fluids keep insects alive during sub-freezing weather. So freezing, sub-freezing. This one's really important because it has the answer kind of right in it. So usually an answer will have a rephrase of the question a little bit. So this one has freezing, sub-freezing weather. How do insects keep alive during the freezing? How do we keep organs alive during freezing? So that's your answer right there. Radioactive isotopes can be used to diagnose condition of donated organs. That doesn't really have to do with anything about freezing the organ. That's about how to find out if the organ is viable or not. So up here, most animals have bodies that exhibit bilateral symmetry or radial symmetry. Bilateral is half and half, so they're mirrored. Radial is like a wheel, you think. There's a center, spokes leading out from that center, and then there's like something around it. So just think radius, radial symmetry, round. If you drew a straight line down the middle of an animal exhibiting bilateral symmetry, the two sides would be mirror images. So you'd cut it in half, they'd be almost identical. Such animals have a front end and a rear end, so a head and a butt is what you're looking at that you can see. On the other hand, an animal exhibiting radial symmetry has a body consisting of consisting of smaller parts arranged around a center. So like I said, like a bike wheel. So here's your bike wheel, and you have spokes coming out, and then something around it, and that's your central. There's not really a head and a butt. So circle the image of the animal below displaying a radial symmetrical body. So if you go ahead and look at this, so salt, marsh, greenhead fly, head, butt, if you cut it in half right down the middle, it would be identical. Dogfish, if you went ahead and cut it down the middle, would be identical, has a head and a butt. Horseshoe crab, also if you cut it down the middle, it would be identical. So, and it has a face somewhere on there and kind of a butt somewhere. So then you have sea stars. You look at this, and it's a radius. So there's your center. Then you go ahead and you have the radius around outside here. So if you look, you're seeing point, 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 point. There's no real head on this. And if you cut it in half, each of these would probably look a little different. If you've ever seen like a starfish, each little tentacle is a little different. So if you look at this radius, your answer is going to be B. So you would just circle that one right there. It's the only one that's radial. It looks like a wheel. So hydrogen peroxide molecules are composed of 2 hydrogen atoms and 2 oxygen atoms. Water is also composed of hydrogen and oxygen, but water has 1 fewer oxygen atom than hydrogen peroxide does. Which of the following statements best describes the chemical reaction shown in the equation? So here's the start of your chemical reaction. Here's hydrogen peroxide. And then you look at the arrow, which is really important because it's showing you what's happening. It's showing you where the chemical reaction is taking place. So hydrogen peroxide is breaking down, and you're getting 2 water molecules and oxygen. So it's being broken down into its different parts. So hydrogen peroxide is being made out of water and air. Okay, the arrow right there tells us it's breaking down, so it's not being made out of these. If this arrow was switched, then that would be correct. Hydrogen peroxide is decomposing into pure water. We have water here, but we also have oxygen too. So that's not correct either. It's decomposing into water and oxygen. So here's your water. It's decomposing water and oxygen. Water and oxygen are combining to make hydrogen peroxide. That's basically the same as A here, and neither one of those are correct. So it's really important that you look at your arrow here and see which way it's going and what's happening. So it's breaking down into 2 waters, or 2 water and 1 oxygen here. So this one gives you a little chart, melting and boiling points of 5 elements. It's also kind of good to know what elements are what. So like what's a gas, what's a metal. Just a quick example, you just like a quick look at that online would be good, just so you kind of know. It might ask some questions like this about elements, and it's kind of good to know what the elements are and what category they fall into. You don't need to know like their atomic weight or any of that stuff, but it's kind of good to know where they fall on the periodic table. So, which of the following statements is supported by the information on the chart? So you look, they're melting points for them to become liquid, basically. So it's extremely high for iron, carbon, and gold. And their boiling points are also extremely high. Mercury and bromine, pretty average, pretty low temp. Room temperature, just so you know, is about 70 degrees. So, it's just kind of good to know. Sometimes it'll ask you questions about room temperature. It's usually about 70 degrees. So, which of the following statements is supported by the information on the chart? So, mercury and bromine are liquids at room temperature. That could be okay. That might be the answer. We'll come back to it though. Iron has a higher melting point than carbon. So here's iron, carbon, melting point. Iron is not higher than carbon. So iron has a higher boiling point than gold. You look at iron and then gold, it doesn't. That's also an incorrect. And then this is where knowing some of the elements comes into play. So mercury, iron, carbon, and gold are all metals. Bromine is not a metal. So that one is also incorrect. So by process of elimination, we're going to go with A. That's kind of an easier way around than knowing all exactly what room temperature is. Basically, it is also saying that mercury and bromine, since their melting points are far lower than room temperature, they're both liquids too. So that's also your answer. But you can do process of elimination too if you're getting stuck and you're like, I don't really know. Just kind of knowing some of the elements and things like that kind of helps out. Also knowing some of the chemicals that are pretty common, salt, hydrogen peroxide, that kind of stuff kind of helps you out a little bit. The U.S. Surgeon General announced that infectious bacterial diseases would soon become a thing of the past. So this is almost 40 years ago that they're talking about this. However, since that time, strains of disease-causing bacteria that are resistant to antibiotics have evolved. Some types of pneumonia and gastrointestinal infections, so tummy infections, are now untreatable by antibiotics. That's because they're resistant to it. So an example of that would be one called MRSA, MRSA. You may have heard of it. It's resistant to antibiotics or any kind of treatment right now. So about 17 million people worldwide still die annually from infectious diseases. Which of the following best explains why the Surgeon General's prediction was wrong? Antibiotic drugs are not effective against most disease-causing bacteria. Well, that's not really an accurate statement. Antibiotics are pretty effective against most diseases. But there's a few out there that are resistant. So it's important to remember that. Infectious diseases are also caused by viruses and parasites. That doesn't have anything to do with what we're asking here. This is infectious bacterial diseases. It's not actually talking about that, so that's just, they're trying to confuse you a little bit. Infectious diseases have remained a problem outside the United States. Well, it doesn't say that anywhere in here. It says 17 million people worldwide. So that can be in the U.S., it can be out of the U.S., it can be all over the world. Who knows? Doesn't really give us a clear answer. So bacteria quickly evolved resistance to antibiotic drugs. So it says that directly in here. Strains of disease-causing bacteria that are resistant to antibiotics have evolved. So your answer is D, because that's the one that's clearly stated in here. All these other ones are just kind of guesses, so you just have to go with the one that's clearly stated. A student did an experiment to see how far a ball would roll on different surfaces. She made 5 different ramps, each with a different surface: a plain pine board, a painted board, a board covered with sandpaper, and a board covered with artificial turf. So if you can picture that, she has a bunch of pieces of like plywood basically, and then each one has some different material on it to see how resistant the ball is to it. She set up her experiment on a smooth level floor to make the ramp, so that's a controlled environment. The floor is level. She raised each end of board with a book. She collected 4 copies of a science textbook her class was using. So 4 of the exact same books for 4 of these. And then she couldn't find a 5th copy, so she used a thinner science study guide to set up the 5th. So the 5th is a little bit lower than the other 4. She rolled a tennis ball down the ramp and measured how far the ball traveled. Then she compiled her data. Why was the student's experiment flawed? So it's going to ask you to kind of really analyze this passage here. The student should have used a ball with a smooth surface rather than a tennis ball. That's not correct, because she used a tennis ball for all of them. If she had used different balls for each one, that would be different. But she used a tennis ball for all of them. So she's going to get that's unchanged. She uses it for all of them. The student should have used books of the same height for all ramps. So that's your answer, because she introduced a second variable by adding a thinner book, so that threw off her entire study. Because now she doesn't know if it's the material that she put on the board or if it's the height of the ramp. So you can only have really one variable in your experiment to have it come out and be valid. She should have not used sandpaper. She used sandpaper and a bunch of different materials. That's part of her experiment. For control, she could have rolled the ball across a piece of wood that was level. It's not really going to give her much information. I mean, that's not what she's testing. She's looking at the ramps themselves and how far the ball will roll off ramps. So your answer for this one is B.